Good morning. Today we'll see about full subtractor. Okay. So first the definition. It is a combinational digital circuit which accepts three single bit inputs to perform subtraction and produces two outputs, namely difference and borrow. So it is used for performing subtraction. Okay, but it performs on three single bits. That's why it is a full subtractor. Then how to design a full subtractor? We have to follow these four steps. First step is block diagram, then truth table, then Boolean expression, finally logic diagram. First we see about the block diagram. So this is the block diagram for the full subtractor. This can also be taken as the logic symbol for full subtractor. Here you have the three inputs, namely A, B and C, and two outputs we have D and B naught. This is borrow output. This D is the difference. Okay. And this is the borrow output. So these two are outputs and these three are inputs. And here this last one is actually the borrow from the previous. Okay. From the previous stage, this comes as the borrow input for this subtractor. Now we are going to derive this truth table. And how do we obtain this truth table? Here we have three inputs, so that 2 power 3 input combinations are possible. That means 8 input combinations. So we start from this 0, 0, 0 for A, B, C, and then we will be getting this D and B naught as the output. Okay, so for subtraction, how do we perform? We have to perform something like this: 0 minus 0 minus 0. So when you subtract, you will get difference. There is no difference between these three bits, and there is no need for getting the borrow. That's why it is 0 and 0. So when you go for the second case, okay, so this is for 0 and this is for 1, 2, this combination is 3, this is 4, and this is 5, and this is 6 and 7. Okay, so when you go for this 1, okay, so it is 0 minus 0 minus this 1. So 0 minus 0 minus 1 means 0 minus 0. So how do we perform? The 0 minus 0 will result in the difference of 0. Okay, after that you have to subtract this 1 from this difference. Okay, so this is out of this two combination. From this you have to subtract this. So when you subtract like this 0 is less than 1, so definitely you will be getting a borrow for that. So this B naught is, sorry, this B naught is 1, you get a borrow. And the difference between these two is now 1. Okay, so you get 1, 1 combination for this. And the next one is 0 minus 1 and then minus 0. Okay, what it is? 0 minus 1. So the difference between these two is 1, isn't it? And definitely when you subtract a 1 from the 0, because 0 is less than 1, definitely a borrow will be generated here. So you get a borrow here anyhow. And between these two we have the difference of this 1. After that you have to subtract this 0. Okay, so minus this 0. So that would give you again a 1. So this difference is 1 and this borrow is 1. That's how we obtain this. Okay, then we go for the next, that is 3. So for 3, what is it? It is 0 minus 1 minus 1, right? So first we do this, perform on this. So 0 minus 1, 0 is less than 1. Okay, so borrow will be automatically generated. And the difference between these two is 1. That 1 minus this 1, right? So this 1 minus 1, now the difference is 0. So you get 0 and 1. Then the next combination is 1, 0, 0. So 1 minus 0 minus 0. So 1 minus 0 minus 0. So first you perform on this 1 minus 0, it results in 1. That is the difference between these two. Okay. After that, you have to do this 1 minus 0. So the difference is now 1. We haven't got any borrow so far generated, so it is 0. Okay, so 1 0 is the answer for this. And the next combination is 101. Okay, 5. For 5 it is 101. So we have to subtract 1 minus 0 minus 1. So what it is, 1 minus 0 is 1, right? And this one should be subtracted from this one. 1 should be subtracted from this one. So here the difference between these two is now 0 and no borrow is generated, so that it is again 0. So we get this 0 and 0. Then when you go for the next two combinations, that is 6 and 7. For 6 it is 1 1 0, right? For 6 it is 1 minus 0. So 1 minus 1, when you do, it is 1 minus 1 is the difference is 0. Okay, and that minus this 0, 0 minus 0, again difference is 0, no borrow is generated, so it is 0 0 again. And the last combination is 1 1 1. So it is for 7, 1 1 1. So what happens for that? 1 minus 1 minus 1. So the difference between these two is 0, no difference. Then this 1 must be subtracted out of the 0. As we all know, the 0 is less than this 1. We have to get a borrow, so borrow is generated, and the difference between these two is 1. So the answer is 1 and 1. Okay, so for this we got difference and borrow as 1 1. This is how we perform this subtraction on this 3 bits. Okay. Now the next step is the third step is to get the Boolean expression out of this. So to get the Boolean expression, we have two outputs, namely D and B naught. So we will be having two Boolean expressions, D and B naught. For that we have to check the ones corresponding to this D column. So if you take the D column completely, okay, into which what are the ones available, we can check this is one that corresponds to this one, and then this one for this 2, and this one for 4, and this one for 7. So we have to check the combinations corresponding to that one. Okay, 4 and 7. So we can write it in like the minterm, sigma m of 1, 2, 4, 7. And in terms of expression, how do we write? D is equal to that 1 corresponds to A bar, this is B bar, this is C, isn't it? 0 represents bar. So this is A bar, B bar, C. For the combination 2, what it is? It is 0 1 0. So A bar, B, C bar, plus for 4 it is 1 0 0. That means it is A, B bar, C bar, and then for the last one is 7. For 7 it is 1 1 1. So you write it as A, B, C. This is how we write the expressions for this difference output. The next step is to write the Boolean expression for B naught. Okay, so for that we have to check with this particular column. So in that column we have ones here. This one corresponds to 1, then this one for 2, this one for 3, and this one for 7. So this B naught output, we can write B naught output is equal to this one for this one, right? So we can write this combination as this is A bar, B bar, C. So it is A bar, B bar, C plus the next one is 2. It is 0 1 0. 0 1 0 means it is A bar, B, C bar. Okay, A bar, B, C bar plus the next combination corresponds to 3, right? So it is 0, 1, 1. So we can write it as A bar B C. The last combination is 7. So it is A B C. So we have completed this expression. Corresponding to this B naught, actually we know that in terms of min terms, it is 1, 2, 3, 7. Okay. This is how we can write this expression as well as SOP form. But in this, this SOP form will be useful when you go for simplifying this Boolean expression using K-map. Okay. But I don't prefer the simplification using K-map because actually it is not giving you the necessary simplification. So I'm not going into that, and I'm going to directly simplify it. Okay. So sorry, this is D is equal to sigma m. So it is A bar B bar C. Okay, right. So we move on to the next. So this is the Boolean expression, and we got this expression already. I have derived it, right? So from this we can go for the simplified one. Okay. So first we start with this D, how to simplify for this. So here you have initially A dash B dash C plus A dash B C dash plus A B dash C dash plus ABC. First you consider we have 4 terms, right? This is A dash B dash C is first term, this is your second term, and this A B dash C dash is your third term, and this is your fourth term. So to simplify, you can check with this first term and the third term. In this, A dash is common, so it is taken outside. Inside we have B dash C plus BC dash plus. When you consider this third and the fourth term, there the A is common, so I take it outside. Inside you get B dash C dash plus BC. Now I can write this like A dash into this expression is what? It is exclusive OR, right? B exclusive OR with C plus A into what is this? This is exclusive NOR. Okay. We can proceed further. A dash, and I'm going to take this as X. B exclusive OR C. Okay. B exclusive OR C is taken as X. So that what is X dash? X dash is B exclusive NOR C. Okay. So this is A dash X plus A into X dash. So what it is again? Again it is exclusive OR function. So A exclusive OR with X. Instead of X, I am replacing the X by the expression what we have already. This B exclusive OR with C. Okay. This is what the simplified expression for this D. Now we have to simplify the next one, right? So that is B naught. We have to simplify this B naught. So initially we have this first term, this is your second term, this is your third term, and this is your fourth term. And we check with this. So for this B naught, you go with this A dash and then which is common? C is common here. We want to have so here this first term is a dash b dash into c. So I am considering this first term and the last term in which the c is common. So if c is taken outside, then I'll get a dash b dash here. Similarly ab here, in which the c is taken outside. So first and fourth terms are combined. Okay. Then here in the second and the third term here, which is common, this a dash b is common, right? So a dash b is taken outside, so that I am getting c dash plus c, and this is equal to, you know very well that this a dash b dash plus ab represents what? A exclusive NOT with b into c plus this a dash b, and we know that the c dash plus c is equal to 1. Okay, so it is 1, that becomes a dash b, and this a circle dot b, that is XNOR, right? It is XNOR. Circled dot is XNOR. So this XNOR is the complement of what? For this, if you take the complement, then it becomes XOR, isn't it? It becomes XOR. If you take the complement, it becomes XOR. So you can write it like A exclusive or B complement or dash into C plus A dash B. So this is what the simplified expression for this B naught. Now we move on to this. So we got this right already. A exclusive OR with B exclusive OR with C. That is our difference, and the borrow output is A exclusive OR with B dash into C plus A dash B. Okay, so for this we can very easily draw the logic diagram. That is the next step. The fourth step is drawing the logic diagram. So I am going to proceed with that. So we have three inputs A, B, C. So for that you can take three lines, input lines. And then I'm taking the connection from here A and then B. So these two are given to XOR gate. Okay, so what is this? A exclusive OR with B. Then again I'm taking the connection from here C. So this is C. Then again it is given to another exclusive OR gate. So now you get the output. That output is A exclusive OR, B again exclusive OR with C. So that this is your D output. Now I am going to draw the B naught. So for B naught I am taking this. So what it is? A exclusive OR with B. So I take the connection from here, this point. This is A exclusive OR with B. And then it is inverted or complemented. So inverter. Then it is ANDed with the C, right? So from this C the connection is taken. It is ANDed. So you get an AND gate here. After that, here you have this A dash B. So A dash B means we can take the connection from here. So it is A inverter, and then B, the connection is from here, and then it is given to an AND gate. Then both are combined using this plus sign, right? So we can have this OR gate. So this is the output B naught. So B naught is what? Here you get A exclusive OR with B dash. It is C. So that here you will be getting A exclusive OR B dash into C. Here it is A dash. Here it is B. So A dash B you will be getting. Then finally you get the B naught. So B naught is what it is? It is equal to A exclusive OR with B into C dash into C plus A dash B. Okay, this is the output we got. Okay, so that is drawn neatly here. This logic diagram. So I have given all the details here, and as a summary, everything is included in a single page. So full subtractor circuit definition, how to design in 4 steps. This is step 1, this is step 2, truth table formation. Then Boolean expression, here it is uptime and it is being simplified and the expression is returned. Then for the simplified expression, the logic diagram is done. Okay, and for this basic Boolean expression also you can draw the logic diagram using the basic gates. Okay, that can also be done, right? And also this full subtractor circuit can be constructed using 2 half subtractors that we can see in the next video. Okay, thank you so much.